Hey guys, so today I have the review for the second 9 weeks test here. Um, a lot of these topics are going to be from the previous test or basically what we took on the midterm. So it would be a really good idea for you to also watch the video for our review for the midterm. So I'll link that either above or below. This is from the midterm review as well, so it's probably important, right? So here you've got your roller coaster. I go into great detail with this in the last review, so I'm not going to spend too much time on it. Just remember about potential and kinetic energy. Kinetic energy is energy of motion or movement, so it's already moving. Potential energy means it has the ability to start moving, or it may be already moving and it's about to start going faster. So that's potential energy. So you're going to always have potential energy at the top of the roller coaster. Lots of kinetic as you're coming down the roller coaster and getting towards the bottom. And then you'll have more potential as you go up the hill again, or once you're up at the top of the hill. So just remember the difference between potential and kinetic. And then the bottom here, it's pretty straightforward. We've already talked about this before. So just mark them as P for potential and K for kinetic. Then we go into the different types of energy and transformations between these different types of energy. So make sure that you review the types of energy. If you're having problems with this, you really need to go back and look at your notes on energy. I'll link those below as well. All the notes for all the different things that we've done for this 9 weeks. So for example, like plants, that's photosynthesis. So we've got radiant energy from the sun that's turning it into chemical energy. The solar calculator is, since it's solar powered, that's also going to be radiant energy, but it's turning it into electrical energy because it's a calculator. If the calculator were to light up, you could even say that it's also radiant energy or light energy. It just depends. So go through these and work these out. If you have any questions, let me know. Then we move on to forces. So when we have balanced forces, that means that there isn't a change. So if something is not moving, that means that it's got balanced forces acting on it. There's no change. It just continues to not move. Or if something is already moving and it just keeps going in the same direction that it's going in, that's also balanced forces. So there's just no change there. Unbalanced forces means there is a change. So maybe something was not moving and now all of a sudden it is moving, or it was already moving and it changes direction. That's going to be an unbalanced force. Net force is when everything is put together. That's when I ask you, okay, well, are the forces working together or are they working against each other? So you're going to have to decide if you have to add or you have to subtract. And then a Newton is how we measure that force. That's the unit for force. And then friction is always going to fight motion. It's going to slow things down. So in these pictures, just figure out if it's balanced or unbalanced. So figure out which ones you have to add or subtract. And then you just circle balanced or unbalanced. Speed. So you're going to have a formula chart, and speed is equal to distance divided by time, and these are just a couple of practice questions. Always be sure to check your units. Sometimes in the question they ask you to give it to them in a specific unit, and that's different from what they've given you. So you might have to convert. So just be careful about that, but it's pretty straightforward. You're going to have a calculator in order to figure these out. So here's just a couple of practice problems. And then we have graphing. So this is really important and it can be a little bit difficult, but I'm going to go through this. And this is also from your last review, so make sure that you know how to read graphs and things like that. So here for number 15, it's asking for the unit of time. And if you look at the x-axis, it's going to be time is in hours. For number 16, the unit for distance, if I look at the y-axis, it's in kilometers. What could be a more creative title for this graph? That's kind of up to you, whatever you want to title it at. And then number 18, it says calculate the average speed at 5 hours. So here, I'm going to go ahead and write on my graph at 5 hours. Here is where I'm at for 5 hours, and we talked about this before. So my time is 5 and my distance is 100. So distance divided by time. So that's how you're going to calculate the average speed for the entire trip. What does the steepness of the line on the graph represent? Number 19. So whenever I have a steeper line, like here, that's going to be where I'm going really fast. And whenever I have a gently sloped line, like here, that's when I'm going to be going really slow. So it says number 20 is asking me to label this one as the slowest. And then number 21 is asking me to label this as the fastest. Okay, I will link the notes to graphing here so that you can go ahead and watch those as well. We have some multiple choice questions. These are pretty straightforward. I just want to point out that number 24 and 25, you're going to actually have to divide. So those are more practice problems for speed. So make sure that you work those out. I'm trying to see if there's any other ones that I want to go over with you. It's asking about units and things like that. That's pretty easy. Let's look at number 27. Which of the following is true when the slope of the line on a speed graph gets steeper? We just talked about that. When it's steeper, the object is moving faster. On to cells. So remember we talked about the cell theory, and this was left off of your review. Sorry about that. So go ahead and write down what I have over here on the left, which is the basic rules or laws about cells, right? So cell theory states that cells are the basic unit of life. Cells are as simple as I can get whenever I'm talking about something that's living. That's what that means. Number 2, cells come from cells. That's reproduction. So life comes from life. And number 3, all living things are made up of cells. So make sure that you know those for the cell theory. Remember, we use a microscope to look at cells, and we talked about Robert Hooke and how he saw the little rooms in the cork. So that's really important too. Then we have prokaryotes and we have eukaryotes. So an easy way to remember is pro, no, you do, right? And here we're talking about a nucleus. So prokaryotic cells don't have a nucleus, so the DNA is just all bunched up in the middle, and eukaryotic cells do have a nucleus. So down here at the bottom, it says circle the eukaryotes in the photos below. Then I just circle the ones that do have a nucleus, and this is from your notes, so you should know this, and there's going to be 5 that we're circling that do have a nucleus. Then we've got a couple of definitions. The cell is the smallest unit of life. An organelle is a cell's organs. And then animal cells are eukaryotic. They don't have a cell wall. Plant cells are also eukaryotic. They do have a cell wall. They have chloroplasts. They have large vacuoles. Remember, animal cells will have vacuoles, but they'll be smaller, and they might have more than one. And then photosynthesis is the process of plants making energy using the sun. So remember, radiant energy to chemical. I'm going to write that down. Radiant, because that's one that they like to ask, to chemical energy. So let's talk about the organelles. These are some of the most important ones. In other words, if I had to bet money that you were going to get questions about organelles, these are the 3 that I would bet money on. So a nucleus is the control center, or like the brain of the cell. Then we have the cell wall, which is protection, structure, and support. And it's kind of like a brick wall around the cell. Remember, cell walls are only going to be found in plant cells or bacteria cells because they need that extra protection, structure, and support. And then I have mitochondria. Those are the powerhouse of the cells. They are the ones that are producing energy. Here you have all the rest of the organelles. Again, if I had to bet money, I would bet money on cell membrane. That's the gatekeeper. So it decides which stuff can come in or can't. I would bet money on the mitochondria. That's the energy producer. I would bet money on the nucleus. And I would bet money on cell wall. Okay, those are the 4 that they will probably ask you about. That doesn't mean you don't have to study the rest. You have to know the difference between plant and animal cells. You have to know chloroplasts. That's a pretty easy one. We know that only plant cells are going to have that because that's for photosynthesis. And while I'm here, go ahead and comment below for extra points. I'll give you 5 extra points on the 9 weeks test if you comment below with what your favorite organelle is and why. Okay, so make sure that you do that before you leave YouTube after studying. Now let's compare and contrast plant cells and animal cells. Plant cells are going to have a cell wall. They're going to have large vacuoles, like a central vacuole, because they need that extra storage. And they're going to have chloroplasts for photosynthesis. Animal cells will not have a cell wall. They won't have chloroplasts. And if they have vacuoles, they are probably going to have multiple small ones, not a large one like plant cells will. And then they both will have cytoplasm, which is the jelly-like fluid. They're both going to have a cell membrane that controls what goes in and out. They're both going to have mitochondria for energy, and they're going to both have nucleuses because they are both eukaryotic cells. Then we have our labeling. This is pretty straightforward. A here, if I'm looking at the top part, this is a plant cell. A is my cytoplasm, B is my chloroplast, C is my nucleus, D is my mitochondria. Mitochondria are always going to have these little squiggles on the inside. E is my cell wall, F is my cell membrane, and G is my vacuole. Down here at the bottom, we have an animal cell. A is my mitochondria, there are the squiggles. B is my cell membrane, C is my cytoplasm. D here is the vacuole, small, right? And only one of them. And well, actually, it could have more. These could also be vacuoles over here. Anyway, and then E is my nucleus again because it is eukaryotic. Reproduction. So sexual reproduction, remember, has 2 parents. I'm going to have high genetic variation. The DNA is going to all mix up and the kids are going to look different for sexual reproduction. Asexual reproduction is only going to have 1 parent and it copies itself and splits. So there's no genetic variation. It's going to be an exact copy of the parent, right? Number 9 is 2 advantages of sexual reproduction. With sexual reproduction, there's going to be more variation. So the kids look different. And if something happens to the environment, like in the Amoeba Sisters video, we saw the grasshoppers, right? There were some greener ones and there were some browner ones, and then there was a drought. And the browner ones now camouflage better, so they were able to keep the population going. So that means that they're going to be better adapted, or some of them will be better adapted. And so if something bad happens, not everybody's going to die off. Some of them will still survive. Number 10, 2 disadvantages of sexual reproduction. You need to have 2 parents. So the 2 parents are going to have to find each other. If there aren't that many individuals, that could be difficult. Like, you know, when organisms are going extinct, that sort of thing. And then also it's going to take a lot longer. The gestation period is going to be longer. So it's just not going to happen as fast. Number 11, 2 advantages of sexual reproduction. You only need 1 parent and it's really fast. The reproduction is really fast. But disadvantages for asexual, there's no variation. So they're going to be less adaptable. If something happens in the environment, there's not going to be any individuals that are better suited for the new environment. And then here we have a few examples of organisms, and so you have to determine if it's asexual or sexual. So you can just write an A or an S for asexual or sexual. Like bacteria is going to be asexual. I'm going to just go through some that you might find difficult, like coral would be asexual, flatworms would be asexual, anemones are also going to be asexual, jellyfish, yeast will be asexual, and so will strawberries. Okay. Then there's something else that I left off of the review, which is having to do with energy transformations, conduction, convection, and radiation. So I want you to stick this at the bottom of your review, kind of next to this box, because there's a little bit of space there. So let's talk about how heat can transfer. So this is my awesome drawing of a pot on a stove. So here you have conduction, like if I touch the handle of the pot, as long as it's metal, right, it's a good conductor, that's conduction. That heat is going to travel through touch. Convection is happening inside of the pot. If I'm boiling water, there's going to be hot water towards the bottom because it's getting heated by the burner, and then so it floats up because of density. And then as it goes to the top, it's going to cool and then sink. So that's a convection current that's happening there inside the pot of water. And then radiation would be going through space. I'm not touching it, but I walk by the stove and I can feel the heat coming off of the stove. So that is radiation. And that brings us to the end of our review. I thank you for watching. You're doing a good job studying and preparing for this test. Remember, it is 15% of your average. If you have any other questions, let me know, message me, ask me, and I will help you. Remember, you are in charge of your grade. You determine how well you do, how much you study, and you're doing a good job starting off by watching this video. If you have any questions, let me know, and I will see you in class. Thanks for watching.